Welcome to EPG Pathshala. Today we are going to introduce the essentials of optimality theory as proposed by McCarthy and Prince 1993, A, B and Prince and Smolinski 1993, and also as illustrated by Rene Kager 1999. OT is a grammar based on the universal constraints which are ranked on the basis of individual languages requirement. So, it is a ordering of the universal constraints on the basis of the requirement of individual languages. Now, it deals with constraints, and these are called constraints because these are not the rules which used to be used by the pre-OT generative phonology. Rules now are replaced by constraints because rules are absolute, rigid and non-violable, but constraints are violable and very flexible, and it is their ranking order that makes differences from one language to another and thereby develops the typology of language variations. Pre-OT or early generative phonology used rules to figure out what is allowed and what is not allowed in a particular language. OT uses constraints and structures, grammars in conflict as systems that map up from one input or underlying form to the output or the surface realization. The basic concepts of OT. The basic concept of OT begins with the idea of constraints. Constraints is a structural requirement that may be either satisfied or violated by an output form. OT grammar primarily builds on two types of constraints, markedness and faithfulness. Now, what are markedness and faithfulness constraints? Markedness constraints are those constraints that stipulate that output forms fulfill some criterion of structural well-formedness. That is, certain structural requirements are there by which we can have a better articulation or processing of linguistic outputs. Second, markedness constraints enforce prohibitions on marked phonological structures such as segment types, prosodic structures or occurrences of segment types in specific positions. For example, vowels must not be nasal, syllables must not have codas, obstruents should not be voiced as in codas, etc., etc. Markedness constraints do not refer to input. OT is a grammar based on the evaluation of the outputs produced by gen and evaluated by eval. Now, faithfulness constraints. This group of constraints require that the output form remains faithful to the input form. That is, the output form should not deviate from the input forms. It insists on preserving the underlying properties of an input at the output. For example, the output must preserve all input segments, their feature values, their linear order, and should not allow any new segments, etc., etc. Another important feature of optimality theory is universality. Constraints are universal and parts of the UG or universal grammar, but all constraints need not be equally active in all languages. That is, in some languages, a constraint may be very strong or powerful and weak in another language. Their ranking variation brings about the changes from one language to another. Underlyingly, all constraints are present for all languages as they constitute the universal grammar. Now, because the OT grammar for each language is made up of distinct variable ranking of the common universal constraints, UG constraints, therefore, the constraints need not be very strict or rigid. Out of this variable ranking is born the typological variation among languages. The next important feature of optimality theory grammar is violability. Constraints are violable, but violation must be minimal. Every constraint in OT can be violated to satisfy the demands of higher ranked constraints. Because, as we have discussed earlier, the constraints are not rigid, they are only hierarchically ordered, so that variation emerges across languages. Every constraint in OT can be violated to satisfy the demands of higher ranked constraints only. This is a major breakaway of OT from derivational rule based models of grammar. Now, this point is important because constraints get prioritized variously in different languages. If in one language constraint A may be very important, but in another language it is less important, in the third language it may even lesser important. So, their rankings will go down according to the requirement of the individual languages. The next important aspect of OT grammar is optimality. An output is optimal when it incurs the least serious violations of set of constraints, taking into account their hierarchical ranking. Now, why we are saying least serious? Because violations of higher rank constraints or multiple violation of the same constraint are treated as serious, but all constraints can be violated, but the violation should be minimum. Therefore, it is expected that violations should be least serious. No output is perfect. There cannot be any output produced by optimality grammar that is perfect or without any violation at all. But the violation should be as minimum as possible. Hence, the most harmonic is called the optimal, that is the constraint which incurs the least number of violations which are not serious are called the optimal or the most harmonic output. Another important feature of optimality theoretic grammar is domination. The higher ranked of a pair of conflicting constraints takes precedence over the lower ranked ones. Constraints are ranked. The ones which are ranked higher exert more power or strength on the evaluation system. The lower constraints which are violated may not have effect or a serious effect on the overall evaluation of a particular candidate. The architecture of OT grammar. The OT grammar is an input-output matching mechanism. Now, it begins with input taken from lexicon, and that input is supplied to gen. Gen picks up any of the inputs and it produces or generates any number of potential output candidates. Now, these potential output candidates, they are potential because any one of them can be the ultimate winner in the next phase. The next phase is the phase of evaluation, and gen supplies all these potential candidates to the evaluator or eval, and out of this eval selects or chooses one of them as the winner. Eval contains a number of constraints which are ranked on a language specific basis, and through the parallel evaluation of all these constraints, a particular candidate of the potential candidates is the winner, and that becomes the optimal or the most harmonic candidate. Components of OT grammar. There are three components of OT grammar. One is lexicon, another is generator, and the third one is evaluator. Lexicon contains lexical representations or underlying forms of morphemes which form the input to generator or gen. Gen generates output candidates for some input and submits these to evaluator or eval. The set of eval is the set of ranked constraints which evaluates output candidates as to their harmonic values and selects the optimal candidate. That is, the most harmonic candidate is the most preferred candidate out of the potential candidates supplied to eval by gen. An important premise of optimality theory is richness of base. It means no constraints hold at the level of the underlying forms or input. Inputs are chosen freely, their structures cannot be pre-decided for scientificity and for objectivity. Therefore, in pre-OT systems, input and output both were in the consideration of the grammarian. So, there was always a scope for duplicacy or a kind of subjective evaluation, because the grammarian selects the input according to the requirement for producing the appropriate output. So, that the scientificity or objectiveness is lost in the process of evaluation. OT tries to get rid of it through this new method of evaluation or choosing the appropriate candidate out of multiple possibilities. All grammatical generalizations are stated in terms of interaction of constraints at the level of output and never at the level of input. So, inputs are free to be chosen, but out of multiple potential candidates produced by gen, eval selects the most harmonic or the optimal one. So, that is how scientificity or objectiveness is assured in this new model of grammar. Another important feature of optimality theory, which is in fact associated with the richness of base, is freedom of analysis. It postulates that any amount of structure may be posited. Only restriction is that these are made up of licit elements from the universal vocabularies of linguistic representations. By licit elements, we mean at segmental level, features and their groupings below the segment, they should not be illegal or illicit, unpronounceable, which are not found in human languages. At prosodic structure level, mora, syllable, foot, prosodic word, etc. Morphology level, they are root, stem, word, affix, etc. And at syntax level, X bar syntax, head versus complements versus specifiers, etc., etc. Selection of input is to be done from such licit items only. Now, how are the constraints ordered or hierarchically organized? A constraint hierarchy, suppose it has 3 constraints and the constraints are marked as constraint 1, constraint 2, constraint 3. In between two constraints, there is a stronger than mark, and it shows dominates over or stronger than. A dominates over B if that stronger than mark is there in between A and B. Similarly, is between C2 is stronger than C3 if there is a mark of stronger than in between the two. A star mark indicates violations incurred by a candidate in case of a constraint. A fatal violation mark is an exclamatory mark after a star, and it indicates that a particular candidate has been ruled out from the competition. A hand with a diaxis fingering towards a particular candidate or pointing towards a particular candidate indicates that this is the winner. Constraints are ranked in a horizontal manner at the top of the tableau, from the strongest one being on the leftmost side and the moving towards the rightmost in the decreasing order of importance. And the potential candidates are ordered vertically on the leftmost column as candidate A, B, C, etc. Another basic concept of OT is transitivity of ranking. By this we mean that if constraint 1 dominates over constraint 2, then constraint 2 dominates over constraint 3, then automatically the calculation is constraint 1 dominates constraint 3. This is meant by transitivity of ranking. OT also proposes an idea of economy. Economy, by this we mean that any particular input can be used for producing any number of potential outputs, candidates. That means there is a deviation from the input on the way to the output. The next important feature of OT is economy. It states that banned options are available only to avoid violation of higher ranked constraints and can only be banned minimally. Now, what is a banned option? In the process of an input being mapped to the output, the input undergoes multiple deviations. It may be less, it may be more. The number of deviations may be less, may be more. But the lesser number of deviations is desirable, because the more deviant the output candidate is from the input, it is likely to be disliked and dispreferred and will be ruled out by the grammar, that is eval. For example, if out of an input like cat, a dog or a mouse is produced as the potential outputs, these will be ruled out by any ranking of the constraints. At the most out of cat, we can think of an output candidate like ka, ku or at, etc. But in no way dog or mouse, because they have no similarity with the underlying input. Now, what is the modus operandi of optimality theory or the grammar based on it? As is shown here, the constraints are ranked from left to right at the top row of the table, and candidates are ordered on the leftmost column, as it shows that all candidates are forwarded to be evaluated by eval. They cross each constraint step by step, and the one which succeeds in defeating or in conquering all the constraints is supposed to be the winner, and that should be the perfect candidate. But the perfectness idea is not there in optimality theory, because no candidate remains without violating any constraint at all. So, it must have some violation marks. That is why the violation should be less in number, and out of that the idea of optimal candidate, not that of perfect candidate, emerges in optimality theory. Another feature of optimality theory based grammar is strict domination. Violation of higher ranked constraints cannot be compensated for by satisfaction of lower ranked constraints. As we see here, candidate A satisfies the first constraint but violates the two lower ranked constraints C2 and C3. And candidate B violates the very first constraint, the highest ranked constraint here itself. That is why candidate B is ruled out. Its non-violation or satisfaction of the two lower ranked constraints cannot make it the winner compared to candidate A. When two competing candidates incur the same number of violations in respect of a higher ranked constraint, then the responsibility of evaluation shifts to the next constraint down the hierarchy. Now, in this tableau, here we see that candidate A and candidate B incurs the same number of violation marks in respect of constraint 1 or the higher ranked constraint, but candidate A also violates constraint 2, but candidate B does not do that. That is, it satisfies constraint number 2. That is why candidate B is the winner in this competition. Another unique aspect of optimality theory mechanism is that when both the candidates A and B violate constraint number 1, but the violation of candidate B is more serious, that is double, than that of candidate A. So, A is optimal. Judgment of lower constraint, that is constraint 2, is not counted thanks to strict domination. Now, this tableau shows that candidate A violates both the constraints 1 and 2, and candidate B violates the first constraint twice but satisfied constraint 2. Now, if we add up the violation marks incurred by candidate A, the number is 2, and so is for candidate B. But the thing is that candidate A violates the constraint, the highest constraint only once, candidate B does it twice. That is why candidate A is the winner, not candidate B. One final property of eval is parallelism. All constraints pertaining to some type of structure interact in a single hierarchy. This hierarchy is quote unquote fixed. No serial judgment is allowed here. Constraints of markedness as well as of faithfulness are ranked in the same hierarchy, and they simultaneously factor out the optimal candidate. Constraints of different domains such as morphology and phonology also share the same hierarchy. For example, in prosodic morphology in optimality grammar. So, in other words, no separate domain of evaluation for phonology versus morphology, faithfulness versus markedness are allowed in OT grammar. This is the beauty of optimality theory based grammar. Now, to summarize the main points discussed so far in this module, now to recap the main points of this module, optimality theory based grammar is a grammar of constraints which are ranked on the basis of individual languages requirements. Constraints are mainly of two types, markedness and faithfulness. They interact parallelly in the same hierarchy. Out of these interactions, the most harmonic or the optimal candidate emerges. This optimal candidate is actually generated by gen from a single input. To sum up the major points of this module, optimality theory is a new theory of grammar in which constraints play a significant role. Constraints are ranked in a hierarchy on the basis of the requirements of individual languages. Constraints are divided into two major groups, the markedness constraints and the faithfulness constraints. Markedness constraints enforce maximum changes to the input so that the result conforms to the regularities found across different languages. Also, they become easy for articulation as well as perception. Faithfulness, on the other hand, militates against any change which is to be brought on the input by markedness constraints. Out of these interactions of markedness and faithfulness constraints emerges the most harmonic or the optimal candidate evaluated by the constraint hierarchy. Languages vary from one another in their ranking of the relevant constraints. Out of these, different types or groups of languages emerge in terms of their constraint ranking variations. This is the source of typological variation in optimality theory mechanism. Many principles and premises have been proposed in optimality theory based grammar. The major ones have been discussed here in this module, and relevant tableaus have been shown to illustrate the operational mode of this new theory of grammar. Different domains of constraints or different domains relevant for constraints such as phonological domain, morphological domain, markedness domain, faithfulness domains all can work together in the same constraint hierarchy parallelly, and that is the beauty of optimality theory grammar. That's all. Thank you.